Light is so fast that everyday life hides its speed from us. Flip a switch, and a room seems to brighten instantly. Look at the moon, and the light reaching your eyes has traveled about 384,000 kilometers in a little more than a second. Sunlight crosses the distance to Earth in about 8 minutes. Nothing with mass can outrun it. In empty space, light travels at about 300,000 kilometers per second. This speed is usually called c. But light is not fast because it has a tiny engine pushing it along. Light travels at that speed because of the basic structure of the universe. Light is an electromagnetic wave. That means it is made of changing electric and magnetic fields that support each other as they move. In the 1800s, James Clerk Maxwell showed that electricity and magnetism are linked. His equations predicted that electromagnetic waves should travel at a specific speed. When scientists calculated that speed, it matched the measured speed of light. That was a huge clue. Light itself is an electromagnetic wave. So, why that speed? The speed comes from the properties of empty space, especially how electric and magnetic fields behave in a vacuum. In a simple sense, space allows changes in these fields to propagate at a fixed rate. That rate is what we call the speed of light. Einstein took the idea even further. In special relativity, the speed of light in a vacuum is not just the speed of one thing. It is the universe's speed limit for information, cause and effect, and massless particles. If something has no rest mass, like a photon, it travels at this speed in a vacuum. If something has mass, like a spaceship or a grain of dust, it can get closer and closer to this speed but never reach it, because doing so would require more and more energy without limit. This is why light speed is not like the speed of a car. A car can go faster if you give it a stronger engine. A photon does not accelerate from rest. It exists moving at light speed. If it is absorbed, it disappears as a photon and transfers its energy. If it travels through empty space, it travels at c. Light can slow down when it passes through materials like water, glass, or air. This does not mean the basic speed limit changes. Inside a material, light interacts with atoms. The wave is absorbed and re-emitted or delayed by the material's electric structure, so its overall progress is slower. That slowing is why lenses bend light, and why a straw looks bent in a glass of water. The speed of light is also why astronomy is a kind of time travel. When you see the sun, you see it as it was about 8 minutes ago. When telescopes observe a galaxy millions of light years away, they see light that began traveling millions of years in the past. The universe is so large that even light's incredible speed becomes a measuring stick for distance and history. Light travels so fast because it is a massless electromagnetic wave moving at the fundamental speed allowed by spacetime. It is not merely quick. It reveals something deep. The universe has a built-in limit on how fast events can influence one another. Every flash, reflection, and sunrise is moving according to that rule.